Alright, hi everyone, welcome to my YouTube channel, City of Electrons. So, of course, we are working on past questions already, okay? And some of the things we've done in previous videos, previous slides, they contain things about past questions, okay? So, yeah, the need for planning, okay, you have things like that in the past question already. And then what's distribution board, different definition of distribution boards in the past question, and then the what's to consider, and we've done this in the previous video. Note that there are things beyond this. This is just like a guide or summary, so you can of course browse more videos online on YouTube. So in this video we are going to do we are going to study this final circuit, what it means and how to go about it. Recall that in our previous video we did this. Where are you? Right here. Okay, where we talked about this. And if you look at this connection here from power line, okay, to meter and then to your distribution board, okay, the distribution board, this whole part here, this easy, this whole path here, distribution, including that meter, okay, let's just rule this part here, okay, the distribution board. Now if you look at this, you will see right here sub-circuits and what? Final sub-circuits. Okay, so what's the concept of final circuits? When we say final circuits, what do we mean? Now, it is a circuit that is connected to a current consuming equipment or element according to the IEEE regulation. Now, no matter how complex that sounds, just look at this diagram and you get the concept. Looking at this diagram gives the pure concept. Power comes into your home, okay, into your distribution board, which is your home, and then after the distribution of power from power line to meter to this your distribution board, it is being spread across different miniature circuit breakers, MCB, different one, 2, 3, just different ones. Okay, we have 8 here. So this is regarded as a final circuit. Why? Because it leads to a power consuming device. It leads to electric bulb, to your ceiling fan, to your cooker, to whatever. At that point where it leads to something that consumes the power, it is not going anywhere apart from there. That's the bus stop, that's the final point. So the name, final circuit. Okay, current consuming equipment or element. Of course, IEEE, just like the body for electrical electronics engineering. Okay, so of course they have regulations. So according to their regulation, we things according to that. So why do we need final circuits? What's the essence? Since we've understood what, or we've seen what final circuit is, why do we need it? For what? Okay, now what we need it for. See, just think of it. Think of the definition and think of that picture I just displayed. I think I should have that picture in this slide, so going back. So looking at this thing, if you have your fan right here, lighting, fans and all those things in this circuit breaker here, okay, now, and maybe you have your cooker in this other line, electric stove, hot plate, whatever, in this other line. Now if there is a fault with one of your, then you have a maybe socket in this other line or something. Okay, now if you have a fault with your cooker, guys, will it affect the lighting? Will it affect your bulb, fan? Will it affect it? Of course not. If there is a fault with your cooker line where you plug your hot plate and all those things, if there is a fault there, this guy will trip off. That means there will still be power in your house, still power in the distribution board, but there will be nothing will affect this side, but this other side carrying a carrying the cooker where there is fault will trip off. Okay, so because of that, we'll say to minimize danger and minimize inconveniences in event of what? A failure. Are we seeing now? So instead of the whole house to trip off, just one sub circuit will do what? Will trip off. Another need is to facilitate safe operation, inspection, testing, and maintenance of the installation. Back to this diagram. If, let's say, okay, yeah, you detected faults with the cooker line. Now you want to fix that fault. While you fix that fault, this side is already, of course, you turn this part off. Okay. Now, meaning there is no power coming from this line into your kitchen. Okay, or wherever you have your cooker. So because of that, you can work on that line, make the corrections, maintenance and things like that, while there is still power going to your bulb, fans and things like that, even still power going to your sockets and any other thing. So with that, there is ease of maintenance. You don't need to shut the whole house, shut power off the whole house. Okay, so these are just basic idea why we need final circuit. Okay, so things to consider when planning final circuit. Of course, you have to consider the number of points that may be connected together. For example, all lighting. Okay, now like we said here, all you can connect fans and bulb and things like that in the same line. Now I've seen a home where the fans are working, the bulbs are working, but no sockets. You plug your charger, there is no power there. That's because all bulb, lights, fans are connected to one line, while the sockets are connected to other line. So how should I group this thing? Should all the sockets be at one part? Should all bulbs and fans be at one part? Fans, ceiling fan, not in those industrial, not those standing fan. Okay. Of course, there are some fans now which have the same have lower rating, so you can plug it together with your light. Okay. So that's one of the things you consider. The number of points. When we say points, we mean load. Okay, we can refer to that as load. Okay, can refer to that as load. So where you have your neutral and your live connected to a load, that's a point. That's a point. Okay, so and then the correct size, another thing to consider. The correct size of a cable for particular duty. Correct size, that's the diameter. How thick is that cable? So of course the thickness of a cable affects the temperature when current flows through it. So if the cable is thick, like really thick, the current flowing through it will lead to less production of heat. Okay, it's not get as hot if the cable is thin. Okay, so if the cable is thin, it will carry less amount of current. Yeah, just like water and pipe. If you have a larger pipe, larger amount of water will flow through. Smaller pipe, smaller amount of water can flow through. If you have a very small pipe and if your wire is very small in terms of size and you want large amount of current to flow through, it will generate heat. Okay, to generate heat, and before you know it, why I don't burn? Okay, so then the third thing to consider is the current rating of fuses and overload devices. Overload device just means protective device like your MCB. So current rating, if you look closely at this diagram, you see current rating. Okay, 20 amps, 16 amps, 16 amps. So what is the correct current rating for the load I want to put in this line? Are we together? Okay, so you have to consider that also. Then the most suitable types of capacity for switch gear. Switch gear, I will do that in the next video, but just note that switch gear has to do with everything here. Okay, everything here. Everything here. The switchgear has to do with that. Okay, but we'll do that in the next video. So consider the most suitable type and capacity. That means current rating, capacity. How much current can that switchgear handle? Okay, before it trips off or things like that. Then another thing to consider is the number of ways. That is how many outgoing circuits. In this case, we have how many? 8. So one outgoing circuit is known as one way. So this one has 8 ways. Okay, so 8 outgoing circuits. So that means the fifth thing to consider is the number of what? Ways. That's how many outgoing circuits. The type, the type, that means category based on function, construction, or application. Type of what? Switchgear. Type of what? Installation equipment. Okay, which has to do with switchgear. So you consider the type of switchgear and then the rating of the what? Switchgear. This is almost like the number 4. But mainly the main difference from number 5 to number 4 is that the number of ways. And then you consider the type of switchgear, type of installation equipment, and you consider the what? The rating of the installation equipment, which is switchgear or protecting devices. Okay. Then to connect final circuits, there are rules. To make connections, these final circuits, there are what? Rules. What are those rules? Of course, the rules are for our good, okay, to keep things safe. So there are rules, and I just have 2 basic rules. Rule here, that is, the total number of points should not have a total rating more than the capacity of the final circuit. When this happens, another final circuit should be what? Used. What do we mean? Back to our friendly diagram, friendly picture. Okay, I said in the previous video that I got this picture from this website here. Okay, amazing website. Right now, what is the meaning of that rule? Now let's take one line. Okay, now looking at this line, what is the current rating here? 20. The rule is that everything, the total or the sum of the load connected to this circuit breaker, miniature circuit breaker, the sum of the load, the sum of the rating, you have a bulb of 1.5 amps or 0.3 amp or whatever rating. That bulb, another bulb, and ceiling fan, different load connected, the sum of their rating should not be more than this. Okay, so if they are connected to the first circuit breaker, the sum of their rating should not be more than this 20. If they are connected to the circuit breaker of 10 amps, the sum should not be more than that 10 amps. Just like that. So that's what this first rule means. That the total number of points should not have a total rating more than the capacity of the final circuit. When this happens, that is, in case the total number of points is more than the rating of that final circuit, more than the rating of the final circuit, which is this guy, another final circuit should be connected. You have a lot of fans, a lot of lights, like you are the light of the world. You have a lot of. So if it's more, the total rating is more than this rating here of your final circuit, then fine, create another final circuit, then send some of those loads here so that it will not be more than. Are we together? So that's for the first rule. Then for the second rule, when connecting final circuits, it should follow a proper order. This is almost like what we've said before. All sockets should be connected together. All these should be connected together. Then for AC, connected alone. Okay, so just that proper order of connection. Don't just mix everything. Okay, so that when you know, so that when something trips off due to a fault, just that line will do a chip off, and everything connected to that line, that kind of thing. Okay, proper order. Now for types of final circuits, okay, we just arranged them in tabular form. So this is final circuit type, the types, and then the uses, and then common rating. Okay, you can have different rating, but these are kind of common ones, and then just little thing to say about them. So final circuit less than or equal to 15 amps. Okay, if you look at this, where is that diagram? Okay, you see that some are less than 15 amps, some are less than 15 amps, these are greater than 15 amps. Okay, now we say then there are some that are less than or equal to 15 what amps. Now for those ones, they are mainly used for lighting and small sockets. Okay, and they have common rating of 5 to 10 amps, that kind of thing. Okay, then of course you may group them. Okay, maybe like 12 to 15 points, you can maybe group them. So of course we understand what the grouping means. That means to connect all lighting to this particular final circuit, all small sockets to this particular final circuit. Okay, that's what we mean by the grouping. So yeah, then another type of final circuit that is greater than 15 amps. Now for such, most times they go for water heater. You see that this one requires more power, okay, more current. Water heater, AC, and then the common rating is like, of course, 15 amps plus. Separate control per unit. Okay, obviously. Okay, separate control per unit. Then for 13 amps, British standard socket outlet, of course general purpose sockets. Okay, and of course 30 amps for ring, 20 amps for radial. Spurs must follow fuse rule. What are spurs? Then of course we have that right here. Okay, we have that right here. So we'll talk about that in this same video. Okay, so in this other slide we'll talk about that in this same video. Now of course fluorescent discharge, this part you may not even include this part. Okay, you may not even include this part, but just note that, just consider these three: 1, 2, 3. Okay, so fluorescence like discharge lightning circuit, tubes used for tube lights, industrial, and tube lights and industrial purposes. But most times we kind of talk about the home. Okay, we'll talk about the home, and you see that their rating varies, including the ones for motor and rotating machines. They vary also. Okay, but for the one for motor and rotating machines, they require overload protection. Okay, require that. All right, so then then this thing, the one I made mention of ring just now, right here, ring and radial just now. Where are you? Yeah, ring and radial. Now for ring and radial, this is also part of the past question, I think number something. So ring or radial. Now for a ring outlet is a circuit where cables form a loop from and back to the distribution board. So power flows in both directions. Okay, now sharing the load and allowing more sockets with smaller cables. Okay, but for radial, the circuit runs in a single line from the distribution board to the last point. So power flows in one direction, needing larger cables and serving few sockets. So the main difference for ring and radial is that ring power flows in both directions, radial power flows in one direction. So what was asked in the past question is the advantage of ring over radial. Okay, I think I have ring over radial. So one of the advantages that's the advantage of having ring final circuit over radial final circuit. So one of the advantages of having ring final circuit is that current for ring circuit, it splits the load between two parts. Like we said, current flows through two paths. So it splits the load between two parts, reducing stress on each cable and improving efficiency. Another advantage of the ring over the radial is small cable requirement. So because of the shared current flow, smaller cable size can safely run the same load, saving costs. Okay, larger cable size are more expensive, more than 2 times expensive. Okay, then another advantage is support more sockets. So one ring circuit can serve more outlets than a radial. That means it's ideal for large homes or high use areas. Then another advantage is better fault tolerance. If one part breaks, the other may still supply power temporarily, unlike radial, which fails completely, because this guy for ring has more than one part. So then the fifth one, which will be the last one here, is that two supply paths, that's lower voltage drop. Two supply path reduces resistance, helping maintain steady voltage even at distance outlets. Okay, so that's for that. Then there is something I said I will talk about. Yeah, spurs. Spurs must follow rules. This guy, look at it right here. Okay, look at it right here. So a spur is a branch or extension taken from a ring or radial final circuit. Okay, so it allows electricity to reach an additional socket outlet or appliance that is not directly on the main loop of the circuit. This is what we mean. So if we have this, okay. Now a spur just mean, note of course these guys are insulated. Okay, these guys are insulated. Okay, I'll cover that. So this is an insulator or a wire. Okay, and this blue part is the insulator, and inside the wire you have the red and then the black, live and neutral. So this spur just mean you tear up, you make an opening. Let me use something else. You make an opening and then you connect, like you tap live and then you tap the neutral. Okay, so this is the spur we're talking about. Okay, that's the spur we're talking about. So yeah, so it's a branch or extension taken from a ring or radial final circuit. We just talked about ring and radial. Now it allows electricity to reach an additional socket or outlet or appliance that is not directly on the main loop of the circuit. See, a fuse spur includes a fuse unit. This is part of the past question, saying that we should differentiate between fused and non-fused spur. Okay, so we can see this spur, but this spur, if you put a fuse there, then it's a fused spur. If you do not put a fuse there, then it's a non-fused spur. Simple as that, straightforward. Okay, so the difference between that, let's look closely. These are the features. Okay, in terms of protection, what's the difference? In terms of safety, what's the difference? In terms of usage and flexibility. So for protection, fuse spur has its own fuse, usually 13 amps, while non-fuse, of course, no individual fuse, just like the name. Okay, then for safety level, of course, when you put a fuse here, the safety is higher, and for this other guy, the safety is lower. For usage, it's for fixed appliance. Okay, like maybe like outdoor points. Then for this guy, note outdoor what? Points. While for non-fuse, it's for one socket only. Then for flexibility, of course, this guy is more versatile, while this other is limited. Okay, so I think we've said a lot in this video. We've said a lot. All right. Then another part of the past question, which I'll quickly touch in. We'll be very fast with this one because we've done something like this in the previous video, and I said it that switchgear here is an assembly of main and auxiliary switching apparatus for operation, regulation, protection, of other, okay, protection and other control and another control of electrical installation. So if you look at this point now, you see this, yeah, like I said, all these parts has to do with the switch gear, including this earth side. I don't have this in zoom, including this earth gear, because this is part of the distribution board. Okay, so all the assembly, everything that's assembly, everything that has to do with the main and auxiliary switch, the switching apparatus for operation, regulation, protection and other control of electrical installation, that assembly makes the switch gear. Are we together? So what's the purpose of the switch gear? Of course, distribution board. Okay, distribution boards and switch gear, because the entire distribution board and that's connection to it, the your breaker that gives power to your distribution board, all put together, it makes your switch gear. So what's the purpose of that? Efficient power distribution. Imagine you just connect from pole, from the power line. You just connect from power line straight to your television. Oh boy. Well, come on guys. So it's really for efficient power distribution, okay, and for ease of isolation of faulty circuits, just like we talked about in final circuits, just like we talked about here. So switch gear for easy isolation of faulty circuits, then protection from electrical hazard, organization of electrical load. Yeah, like organization of electrical load. Of course, this means that our final circuit is also part of the switch gear. It's the final part, like take it out of the switch gear to your different loads. Then compliance with electrical safety regulation. We talked about EEE, that they have their regulation. So in compliance with that regulation, so that's the purpose of having a switch gear. Okay, so the thing is this: we don't make use of all loads at the same time. Sometimes when your TV is on, the fan in your room is not turned on, okay, it's turned off, and maybe your heater is not in use. At that moment, maybe you are just using the light in your parlor, and then the fan, and then the sockets, you are charging your phone, and then the TV, making use of, you're watching a movie or something, but your heater is turned off, your hot plate is not in use. So you don't make use of everything at the same time. Are we getting it? So diversity factor just means the maximum actual load. That means what you are making use of, okay, over the total installed load. So both what you are making use of at the moment, what you are not making use of at the moment, everything installed in your home, everything, all the load put together. That's what we mean by total installed load. And we are going to divide the maximum actual load, what you are making use of at the moment, by the total installed load. That will give you your diversity factor. Okay, that means your diversity factor will always be less than or equal to 1. Equal to 1, it means you are using all the load, all total. If it's equal to 1, meaning you are using total installed load. That means total installed over total installed. That means that's where you get to 1. Maximum actual load, of course, most times will be less than your total installed load, because you don't use everything at the same time. It's rare, okay, it rarely happens. So yeah, so this means that we assume not all appliances will run at the same time. It helps engineers design smarter systems that save costs and space, okay, since you will not use everything at the same time. It's really rare. Now, why is diversity factor important? It prevents oversizing cables, boards and switch gear. since we are not going to make use of everything at the same time, that means once we connect to this particular miniature circuit breaker, we can actually use a cable of smaller size, diameter, thickness, because we know that yes, we have a lot of load here, but we are not going to make use of all of them at the same time. So we are not going to consume to the total power at the same time. I mean, we are not going to consume up to that power. So we consider that, and then we choose our cable size based on that. We can reduce the size of the cable we buy or we install based on that fact to save cost. Okay, well, of course, if you have a lot of money, you can just go for the size, the proper rating. Okay, because for companies or industries, they have to use the actual size of the cable, because sometimes they may have so many things running in an industry, okay, in an industrial setting compared to domestic setting. So why diversity factor? To prevent oversizing cables, boards and switch gears. Now, to reduce cost of materials and installation, I said that just now about getting a smaller size, and of course smaller size means less cost. Then matches design to real world usage. Consider how it's being used, the comparison of how domestic homes, how power is used domestically and how it's used industrially. So with that real world comparison or consideration, will make our installation and then buy the proper materials on that. Now also it ensures what? Safety without waste. Since we know how much power we are going to consume, considering that, we can manage the cable size and some other switch gear and some other things, manage it in a way that we still maintain safety and we still save cost. That means we don't waste money, okay, because money is important, guys. All right, so yeah, yes, okay. I think I've talked about this. Yes, I've talked about this. We did this in when talking about final circuit. Yeah, we did that here. I'm just trying to cover as much as I can in this past question before. Yeah, I have. I think I'll stop here and continue the remaining part of the past question. Continue that in the next video. So yeah, thanks a lot for watching, and I'll see you in the next video. Like, share, subscribe. Thanks for watching, and then bye for now. Leave comments too. Comment.